Import is going to understand that we want to. Thank you. All right. So we've imported our CSV file, but we said the process is very similar to Excel. So we've really not missed anything from the recording, okay? The processes are just similar. What you just need is make sure that you are pointing to the Excel file, all right? Here we pointed to the CSV file. Now we are pointing to the Excel file. So we're going to run this, file_Excel. And if you come here, my environment, you can see the full length, the full path of my file, okay? But on your own computer here to manage package, to manage your directory, because it's very easy. Even though I can copy this code here and share it with you. It's going to link up to the path on your own system. I didn't really notice. So, okay, so we're going to import our Excel, and I want us to see something unique. Again, before we do that, look at our CSV. Look at how it printed the dates. Pay attention to the date column. Okay, let's import our CSV. I mean, our Excel now. Okay, it's printing a lot. Let's format this, okay, by saying set class plus children. All right, so that print, look at the date. Can we see what Excel has done? Who can tell me what the meaning of this in the chat box in a moment? Can anyone guess what this DTTM means? I mean, just tell us in the chat. Excellent. Thank you. So Excel has converted my standard dates into a date time. Did I ask Excel to do that? How you manipulate dates is not really the same thing as how you manipulate date time. All right? I can show us in a bit. If I just come here, recall we used type of yesterday. If I say type of, okay, we have not saved this. Let's save this as DF Excel. Now press my Alt minus and we'll run it again. So if I call type of, or okay, sorry, we're not ready. I'm going to run this again. There's one more thing we have not done. I guess I got too carried away. So we need to also add then plain names so that the names are the column names are properly formatted. All right. So if I come here and do type of on DF Excel $Excel dates, because I want to see the type of that date column specifically. Sorry, not typo. If I call it class, there is a class function. Class. You see the class for this one. Let me change this to the one of the CSV. You see that they are completely different. This is the date object. This is something called POSIX, right? So what we're trying to say is that Excel messed up our data. Okay, and one particular thing we say that software, as much as possible, should do is that be lazy. Being lazy will mean don't do anything that I have not instructed you to do. Just do as much as I have told you to do. We didn't ask Excel to convert this to date time, all right? Again, somebody is asking, how do you get the CSV file? Now, I'm going to copy the URL again. I hope that none of us really has network issues because it's going to be difficult to keep going back and forth. I'm going to put it here once again. That's how we got the CSV. And we didn't have to download it ourselves. We just used this download function. So I'm going to also copy this download function and downloaded a copy of our CSV into our computer. Okay. So not this. Okay. So I'm going to just copy everything from here and put it in the chat box. Okay. Right. So that's for CSV. Okay. Let's see what will happen if we try to import the text file. Okay. So again, just before we go ahead, for this particular data, we have one more headache. We'll probably have to find a way to convert this date column back to date and not date time. All right, if we are using Excel. Okay, but for now, let's go to the text file. For the text file, please, you won't be able to use the import function. All right. So for text, you will have to use a function called read_delim. The read_delim is from the reader package. As you can see here, it's from the reader package. But before we use the read_delim, we also need to state the link to the text file txt is here data demo_data.txt. All right. We'll send that to the console by clicking run. And then read the link, again, the file, the link to the file. And then the next thing that comes is an argument called delim or delimiter. It's asking you what kind of delimiter it is. You usually don't have to worry about this. How will figure it out? So I'm going to just delete this. All right. I'm going to send this to my console and we'll see what happens. Boom. I has figured it out. Okay, and we have it. But this becomes even more messy. I'll expand this, and I want us to look at it again. Look at my date. What date format is this one? Now I have it as day, month, and 2 digits here. But that's not what our original CSV file has it as. It has it as 4 digit months, 4 digits here, 2 digit month, and 2 digit day. Again, Excel has done this to us. And it's even not recognizing it as date now. Instead, it's recognizing it as character. Because, like I told us again, the only date format, like I told us yesterday, the only date format R recognizes is the standard ISO 8601. 4 digits here, 2 digits months, 2 digits day. So if it is not in that format, R will read it, but will not recognize it as a date. So it means we have the headache of figuring out how do we make R recognize this as date. All right. Okay. So let's start dealing with this one first. But before we do that, let's complete this particular reading. We're going to call it df_txt. All right. I'm going to remove this one, comma, and then we're going to put plain names, right? So we say read the text file, then plain the names. So let's deal with this one first. We want to make all the 3 of them. We want to make them look alike. We're going to print them out one after the other. This is DF_CSV. It looks like this. This is DF_Excel. It looks like this. One particular issue is with the date column. This is formatted as datetime, and here for text. It's also one particular issue. Date is formatted as character. All right. So let's deal with the first headache. Let's convert this date to date format and not really character. Okay. So I'm going to come here We want this df_txt to look like our df_csv. I'm going to say df_text, which is our data. Then, when you want to manipulate columns, there is a function called mutate. Mutate is just like the English meaning. You're changing something. So you want to change a particular column, all right? So you have to specify the column you want to change. Then you want to change date, but you also want to rename it as date, all right? So date equals, okay, let me print df_text. I'll use it to explain. Right? So we want to format this. What we want to do is we want to format the date from this day, month, year to recognize as date, right? So recall that when we were loading our packages, there is a package called Lubridate, and we said it's for working with dates. So this comes in handy now. In that Lubridate package, there is a function called day, month, year, DMY. So how you use it is that you look at the current formatting that you have here, and we have agreed that this is day, followed by month, followed by year. Day, month, year has sisters. Any combination of month, year, and day. So you can have it as year, month, date, or day, or month, day, year, and things like that. Any combination that you can have. But this particular data, we said it has it as day, month, year. So we're using the DMY function, all right? So we're saying that change this particular date into a date following the day, month, year format, and save it as date again. So just change the column. Don't change the column name. Don't create a new column. All right. But let's say we want to save it as new date, for example. All right. So we just do that so that we can see. I'll run this. You see that we've created a new column at the end called new dates, and it follows our standard day, month, year, 4 digits. Yeah, I mean our standard year, month, date, 4 digits year, 2 digits month, 2 digits date. And we didn't overwrite the former one. But this is really not what we want. We want to overwrite the former one. We don't want to start creating unnecessary columns. So I'm going to change this to date. Overwrite the former one. Right? Boom. This looks exactly like our DF Excel now. All right? If you like, you can call it df_text formatted. df_txt formatted. Right? Or save it. Okay. So we've dealt with the text issue. Now we're already doing data cleaning, right? Because sometimes you get your data into R and you realize that the format for some of the formats are not exactly what it's supposed to be and makes it difficult to work with. So this is more of data cleaning. So this is more or less like supposed to be here. So I'm going to copy all this down to our data cleaning section. Okay. So we've dealt with that of text. Let's look at the Excel again. Okay. So how do we deal with this one? We say df_Excel. Then recall yesterday that I said you can, when we said something like this, that if you write 10 with a quote, we said I will recognize it as a character, right? But we said if you call a function called as .numeric, we will force it to become a number. Or yesterday we actually said as .double. Okay. So what I'm going to do for this DF Excel here is I'm going to tell R that I want to mutate because I want to change this column. Again, we'll start by calling it new dates equals as underscore dates. Right? Date. We say change this from date time to date. Okay? So let's run this now. Hold on. Okay, it's not doing that. Okay, so okay, so I'll have to come back and look at this and give us the response to this before we finish class. I was actually expecting this to convert to today, but this right now is still keeping it as the date time. So we'll come back to this in a bit. All right. So we'll go ahead to the other things we want to do for the sake of our time. All right. And what we'll be doing right now is that we want to look at our sex column. Right now, if you look at this sex column, you can see that we have male. For some of them, they're in small letters, and we have one particular one here that is written in capital letters. And we don't even know if there are other ones that exist like that. Okay? So we want to look at that and see how many unique entries of sex do we have? How many unique entries of states do we have? Don't forget that our researcher told us that there are 6 states and told us also that yes or no is supposed to be 2. So we want to see how many unique entries of each of these things do we have. So we'll be calling the unique function, all right? And going forward, we'll be working with the df_csv, and we'll look at $sex, all right? The sex column. We expect 2. Let's see how many unique entries we'll have. Whoa. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 different ones. And you agree with me that this is relatively common in data, where you have, especially when things are not coded, and different people write these things different ways. Somebody has probably written it as small letter, somebody is writing it as capital letter, but single letter, and then somebody is writing it this way. And then this is trouble. We can't continue working this way. We'll have to format this. Oh. So thanks. We'll just go back to me. Yes, please, coming back to the df_excel. I completely forgot that we created a new column called new dates, new_date. So I kept looking at this date. So yes, this really did work, all right? But what we want is not new date. So we're going to run this again. And we see that now our date is properly formatted, all right? And we're going to save this. And we're going to save it as df_excel formatted, all right? Or it's this. And we're going to run this for the last time. So thanks, really, for a moment. And these things happen every once in a while, all right? You don't get what you, or you get really what you expected, but you're looking at somewhere else. Right, so coming back to this unique $$sex, we can see that we have 8 different ones, all right? So we look at our df_csv again, all right? So we want to see the unique for state, unique df_csv $state. Again, we're expecting 8. Let's see how many we have. We're expecting 6. We have 1, 2, 3, 4, 5, 6. Good. There are no issues with this one. All right. Let's look at the married. Unique df_csv $married. Let me add comments to these things in a bit, please, before we continue going ahead. I think these ones are really self-explanatory. So I'm checking unique set entries. This one is checking unique state entries. This one, checking unique married entries, right? Okay, so we run this, and we have just two, exactly what we expect. So the state column and the married column are what we expect. The only place where we have issue right now is with the sex column. Okay, so we have checked all of them. Sex, state, married. But the other thing we'll probably also notice is that it is either one of six. So it should actually be a categorical variable and not character. And we said in R, categorical variables are recognized as factors, all right? Also, yeah, married is just yes or no, dichotomous variable, right? So it's better saved as a true or false, where true is equivalent of yes, and false is equivalent of a no, right? So we have to convert three things we need to do next. One, we need to format sex so that it recognizes just male and female and not all these 8 different entries, and make it a factor too, because it's supposed to be a factor. So 2 things with sex column. With the state column, we have to convert it to factor before we continue. Married column, we have to convert it to logical. So we work with these 3, and then we come to the next one, which is the blood pressure, right? And yesterday we said blood pressure here is actually 2 variables in a single column, because this is the systolic blood pressure and this is the diastolic blood pressure. They're supposed to be different. You have to split this single column into 2 columns. Whoa, how are we going to do that? We'll see in a bit. Right, so let's continue explaining our data, all right? So we're going to take our df_CSV, let's say changing sex entries into just male and female. No, female. I love keeping my things in small letters. So I'm going to use all small letters all through. So that's what we want to do now. How do we change our column here under sex into just male, female, and all these 8 different entries that we have? So we're going to call our df_CSV. That's the name of our file. Then again, it's mutate because we're trying to transform a particular column. All right. So we're going to call the notate function. How do we then mutate? I love first creating a new column. So I'm going to call it new sex because I'm going to go back here. So we see the unique entries again. I'm going to leave it on the screen. We have 1, 2, 3, 4, 5, 6, 7, 8. So I'll think through this. I'll say, is there a way for me to tell R that all appearances of this, and this, all them male, as a small letter male like this. And every other appearances, call them females, as small letter this. How to get that English? All appearances of this, and this. I want to call them male. Every other one, call them females. So we're going to try and do that. There is a function called if-else, if_else. It's actually in the deep layer package. And what it does is that it takes 3 arguments. Basically, but most often we use the first 3. If condition, what will happen if the condition is true, and what will happen if the condition is false. So the condition is if x equal m. Recall we talked about this yesterday. Okay, or sex equal the other one, capital letter M, or sex equal this, or small letter male, or the last one, sex equal male. Better still, let me put this side by side so it becomes easy for us to read. So this is the condition. So what do I want R to do when all this is equal? Let's call them this small letter male. All right? If they are not, if that is not true, call them female. Hope this makes sense to someone. I'm asking R to check instances where you have M for male, capital letter M for male, or small letter male, or capital letter M in male. Change all these instances to all of them small letter male. And then every other instance, just call them female. Okay? So I've selected all the male out and I'm renaming them male. Every other person, I'm renaming it as female. Okay? So I could have done another, I could have stated all the other options, but if it is not this or this, sorry, pardon, if it is not this or this or this or this, every other person is a female. So I don't need to start listing that out. These are mutually exclusive, right? So let's send this to the console and see what happens. Okay, so I have my new column. And it appears I have just male, female, this. All right. Let us just be sure I have that. Recall, up here we use unique. I'd like to introduce that to another way you can actually check unique entries. But this time around, not a unique function. Now, this brings me to one major thing I almost always say in R. There are multiple ways you can get the same results, right? So don't be surprised if some people do things and you do something else. The functions they are using are different, but you end up getting the same result. Happens. All right? So the O on my computer, I use a Dell Windows computer, is shift and the button under my backspace. All right? It's just that vertical line. Okay? We looked at it yesterday. Okay? So I want to introduce us to a function, not unique, but can help us know the unique entries underneath sex. Okay? And that function works with our pipe. This operator, we call it pipe sometimes. I can just say then check for distinct entries under new sex column. Unique that I cannot use with my pipe. For example, if I try to use unique here instead, you're going to see that I'm going to throw an error. All right? Because unique is not built to work that way. You see, I have an error. Okay? So if I want to check for distinct entries in this instance, I will use this particular function that is built to work with my pipe. It's called distinct. Okay? So if I run this, I can see now I have just two, male, female. So I think we're good with this column in terms of having just two outcomes, male, female. Okay, so I'm going to remove this distinct. It was just for me to check. And I'm going to rename that column. I'll remove this new, all right? So I modify the original column and we have it this way. This is good. One more issue with the sex column is that we need to now make this a factor. Okay? We need to make it a factor, all right? So we're just going to put a comma here because now we're still transforming a column. So we're still using the same mutate, right? So you can use mutate instead of calling mutate multiple times. You can just put a comma and then do your next mutate entry, all right? Again, it's still the sex column we want to work on, but for now, I'll create a new column again so that we see how it is happening. New sex, because now I want to factor. So we call the factor function. So we're going to say factor, what column do we want to factor? We want to factor the sex column, factor sex. And we want to tell it the specific levels. What are the possible options that you can have? And we're going to state that there are just 2 of them, male, female. If you want to have any as a level, you can also put it here that in case people did not put their sex, just call it not applicable or something like that. You can put the 3rd one. But for our particular entry here, everybody responded. So I won't put the 3rd one here, all right? Okay, we don't have empty non-respondents. So everybody completed, we know their age. Okay, so this is fine. So we are changing column sex to factor, and we are specifying that it has just 2 possible outcomes, male, female. Again, don't forget yesterday, you use this C function when you have more than 1 possible elements or more than 1 possible entries, all right? Okay, you surround it with this C function. And we're assigning it to a column called new sex. We're going to run this again now. Perfect. We have the new sex column and it's a factor. Okay. I hope I'm not too slow. I hope I'm not too fast. So if you're still with me, please just let me know in the chat box. Too slow, too fast. Thank you. All right. But we don't want to create a new column again. So I'm just going to change this and override the original one. Okay. And we're going to run this again. Good. So we've done 2 things. We've cleaned up our sex. Now has just 2 possible outcomes. Okay. And it's now a factor. Let's move to states. I'm going to print the unique entries again so we see it and we're able to work with it. So thanks for the feedback. Going well, doing well, moderate. Thank you. Yes. All right. That's good. So these are the unique entries. All we just want to do is we say these states are fine. There is no abnormal. There is nothing abnormal. We just want to change it to factor. This becomes very easy. Right? So we're just going to put a comma here. And we're going to say we want to mutate state and it's changing it to factor. Because the column we want to factor is state and levels equals. I'm going to state all the 6 states. Reverse, capacity. Please be careful. If you have spelling error here, you're going to get a result you don't want. All right? So you have to be very particular about this. R is very, very saucy when it comes to spelling. Okay? For example, again, don't forget I said it is about R being lazy. R will do exactly what you have asked it to do. It won't do any interpretation for you. Oh, I think you made a spelling mistake here. No. All right. So you have to be very, very careful about your spellings. Okay, so we're changing this state column. We're changing them to factor. And we should have it as that. I think our code fits. So let's run it. Boom. We have state as factors. This is good. One more column. Married. But we don't want to change it as to factor. We don't want to, we said we want to change it to logical. True, false, right? So let's see how we do that. I'll create new married for now because I'm going to use something similar to our if else up here. Okay. Okay, somebody is asking if you have rivers. I'm guessing the person is saying that you have rivers spelled in 2 different ways. That's a different thing. And honestly, I wouldn't really want us to go into that, how you handle that. Maybe it's an assignment. How would you handle it if you have had rivers maybe written differently, more than one way, more than one form? Somebody is asking, is there Kaduna? Yes, there is Kaduna there. I'm going to run the unique again, and we can see that, the unique states, and we can see that we have Kaduna here. That's why we have specified the 6 possible states out as our levels, all right? So going back to married now, we're not changing married to a factor, yes or no. We want to change it to true or false, which is logical. So I'm going to use my if-else function here. Probably might have guessed. If-else sex, otherwise keep it as false. Very easy. I assume. At least it's very. If you have 2 different spell states, there are multiple ways you can do it, but if else might be a possibility. All right. But there are other ways, yes, you might be able to deal with that. Unfortunately, for the sake of our time, we're supposed to have just 20 more minutes. And for the purpose of this class, since we did not have it this week, we won't be venturing into that. Thank you. All right. So we're changing our yes, no to true, false. And we're saying, if it is not a yes, we already know it's a no. Right? So we're saying change all yeses to true. Every other thing, change them to false. Okay, so we're going to do this now. We'll run it. We'll call date new underscore married column. And we can see, boom, it's logical. All right? And we have it as true or false. Okay, but we're not trying to create a new column. So I'm going to remove this. I'm going to call it married. All right? So let's run this again. So we have our married column as logical, true, false. Again, please, I'll just quickly like to say this. True in R, true and false in R are always written as capital letters. Some programs write them as small letters. Yes, for example, JavaScript. But R will always write our true and our false in capital letters. The other thing is that you can actually write true as in just letter T, okay? And false as in just letter F. R will recognize that you have written true or false, but I generally advise against doing abbreviations. And we can see we've gotten the same result. And R is not abbreviating for us, even though I recognize that we did abbreviation, R has written them in full. So please, it is advisable you try to always write your true and false in full. So we've dealt with the sex column, we've dealt with the state column, and we've dealt with the married column. The next thing we want to do is, number one, we might want to convert our, because we need to calculate BMI. And BMI is weight in kilogram over height in meters. So when I want to create, we'll have our height in meters. I want to separate this blood pressure column. I want to separate them into 2, systolic blood pressure, diastolic blood pressure. Okay, so let's keep with our data manipulation. All right. So the next one is height meters. I'll just call it height M equals height CM divided by 100. Yeah, we're creating a new column called height in meters, right? And we're going to take our height in centimeters and divide it by 100 because 100 centimeters makes 1 meter. All right? Okay, so let's run this again. What did I do? Okay, so okay, right. So sometimes you get this kind of things. Again, it's not really surprising. So we just need to take a moment to figure out what our issue is. Problem with mutate column item mutate is not applicable method for mutate. Right? So our height is this. We want to divide this. Just give me a minute. This. Okay, so right now our R is not taking this. Oh, thank you. Somebody already dropped this for me in the chat box. Again, I got distracted. Thank you, Jonathan. Please not mutate. We don't need to call mutate at all. Because we already have mutate here, all right? We just want to take our height and we want to divide it. Our height in centimeters, we want to divide it by 100. So this is exactly what we need to do. So we're going to run this. This is fine, perfect, all right? Because again, we didn't call mutate in front of any of these ones, all right? So height equals height in centimeters over 100, and then we get this. Okay. All right, thanks again, Jonathan. So we have dealt with the height, and then we can go ahead and calculate our BMI, all right? So we can say now, BMI, we can want to call it BMI underscore calculated equals weight underscore kg divided by height in meters exponential 2, right? We said when you want to square something, you use the caret sign. So we're taking the square of height and we're using that to divide weight to get our BMI. Then we want to compare it with this standard BMI that the person gave us. Are they the same? So let's run this. Uh-oh, these numbers are not the same. Now we can see that there are some slight variations, right? So we can easily go back to the person and tell him or her, having original data does for you, right? So we know that already. BMI the person calculated is wrong, right? Ours is correct. So one more thing we need to deal with, the blood pressure column, and we'll almost be done with this. We need to split this, right? But this time around, we're not going to be using a mutating function because we'll have to split into two different columns. Maybe somebody might have guessed that, oh, is the function we're going to be using called split? Something close to that, but we're not using a split function. Okay, so then instead, we're going to be using a function called separate. Of course, what separate does is that it separates a column, right? So we call the separate function, and then we tell separate what was into what. And we're going to tell it we want to separate into two columns. The first column, call it BP underscore systolic. The second column, call it BP underscore diastolic. All right? And then it's going to ask us, where do you want me to separate? At what level? Sep equals, we're going to say at the / junction is where you separate, okay? Then the last one is going to ask us is, convert equals, okay, let's take it one after the other because it's giving us the suggestion here, right? It's asking, do you want to remove the original column? And it has set default answer to true. So it's going to remove this original and replace with these two new ones. Yes, that's what we want. But if you want to keep the original one, you're going to set your remove equal to false, but that's not what we want. We want it to remove. The convert is going to say, if I notice that maybe the original column is character, but the new columns I'm creating, I'm thinking that they are something else. They are not character. Would you want me to convert them? And the answer is true. Yes, we want you to convert them. Okay? But before we do that convert one, I'll remove convert. Now, so we can see what will happen if we don't put the convert. So I'm going to run this. Then we can see that it has replaced this our BP here. That's replaced it with BP underscore systole and BP underscore diastole. And if we check again, let's just double check. The first one is 126 and 108. The second one is 190, 106, 91. Perfect. So we'll run this code again, and we'll see that it does that conversion for us, and we can see that they're not seen as integers, which are numbers. This is good. We're taking our data, and we have done good cleaning to it. One more thing, let's save it. Let's assign it a name. We're going to call it df underscore csv underscore convert to integer. So I noticed that these are just numbers, no decimal places. So R has taken the best guess. These are integers, I know, because I can't see any decimal place. If there were to have been decimal places, R would have called the double. Go today. Okay, how do you save? Don't forget that we have created our script. Let's just go ahead and save right now. And you see this column, this. You just click it and press save. Or you press your Ctrl S on your computer for save. And your script will be saved. That's all. And then we see that question one, how many respondents from each state? So we're done with cleaning. So we're in the exploration now. Okay? So how do we do that? It means that we have to count how many rivers do we have, how many FCT, how many Lagos, how many Sokoto, how many Abia, how many Kaduna. Okay? So we're going to take our DF underscore CH. I'm going to say count for me. Okay? Right. How do you save as CSV or Excel? To that today. We'll look at exporting tomorrow, right? But I'll show us how you're going to export your results. Okay. So the first thing is, I want to answer this first question, and you can put it as run. Okay. and it has given us the name should be used. And this number to the lowest one. So if I put sort equals true, R will do that for me. So I'm just going to run this, and then we can see that the highest number of respondents came from FCT, and the lowest number of respondents came from Sokoto. All right. We've answered CSV. Let's see. The ask us how many are from each state. Okay, so we said you're going to use a function called count. In your right, don't put, and we do this, I will give it a default name called N. But we don't want it as N. R gives us the opportunity now run this, and we'll see that it has done it. It has renamed it, number of respondents. But it's not in a particular order. And I want it to be from the highest to the lowest. Which state has the highest number of respondents? So I'm going to add one more argument called sort equals true. So I'm saying after you are done counting, also sort from the highest to the lowest. All right, about 2 more questions to answer today. We're going to answer all the questions that don't have to do with plots, and we're going to plot our graphs tomorrow. So it says, how many persons have hypertension? So that's the next one we want to answer, right? Hypertension. If somebody is asking a quick question, when we move directory, would it affect our RStudio project? The answer is no. As long as you are moving the whole project directory, it won't affect your RStudio project at all. And that is why I can zip all of these things, for example, and share it with anyone. That's one of the benefits of using RStudio project. It won't affect anything you do. Right? Thank you. To go up, and the second question says, I'll just copy that. Says how many persons have systolic hypertension? Again, we already know that systolic hypertension for the purpose of this class is blood pressure systolic blood pressure greater or equal to 140, right? So we're going to try and answer that in a bit. So we're going to say df underscore CSV clean, that's our data. Then, how do we now do this? No problem. We'll also do counts. But what do I want to count now? I want to count BP underscore systole greater or equal to 140. Does that make sense to somebody? Only count occurrences where the systolic blood pressure is greater or equal to 140. And those will be the number of people with hypertension, right? Again, we want to name it because number of persons with hypertension, let's call it HTN, that's that. All right, so let's run this. Are telling me that 6,697 of them have systolic hypertension and 3,303 don't have hypertension. Okay. Somebody is asking, can we use filter? Absolutely. But the issue with using filter, which I'll do, somebody is asking us to do this. df underscore CSV underscore clean, then filter is a new function we've not seen. So filter is going to use a criteria to give us a particular output. So we say, give me everybody who has a systole greater or equal to 140. R is going to do that for you, but it's going to return every occurrence, will not give us a number. All right, so let's try that. So you see, it's returning all the 6,697. Then you probably want to now go ahead and say, then count BP systole. Something like this. It depends on exactly how you want it. Now, even you can't use count. You probably say, tell me the number of rows. N row function. N row says, tell me the number of rows, right? So you run this and then it's going to tell you have 6,697. Again, this really depends on exactly what you want. If you want to get the number 8, you have this and it tells you hypertension 6,697. But if you don't want it in a tabular form and you just want a single value, then you might run this and it gives you your 6,697. All right. So let me put all here. All right. So we've answered question number 2. Just one more question and we'll be done for today. Thanks for staying tuned. I hope, again, it's really not too fast and not too slow. Okay. Good question from Ginika Chukwu. What if you want to know the number of people with blood pressure, high blood pressure per state? That's also very possible. I'll just do that straight in the console because the person didn't ask us that, so we can move on. But before I do this, let me just quickly post our third question. I'll come and answer it. So in a moment, we'll come back here. I'll copy it and paste it in the console. All right. And then you recall that what we did here is we counted BP systolic greater than 140. If we say count states, then BP systolic, you can tell R exactly how many things to count. So the first thing you are saying here is count states, then count BP systolic greater than 140. It's going to give us the occurrences for each state. So for Rivers, we have 1,093 people with high BP. You can now come here and now say, you might want to now filter only the true if you want, all right? but we have the occurrences for each of the states. For Rivers State, for FCT, for Lagos, for Sokoto, for Abia, and for Kaduna. We have the number who has high blood pressure, for example. I hope that answers your question. All right, so let's quickly answer the third one. Again, for the want of time. So it's saying for each gender in each state, what are their average age, the average height, and the average weight? It's asking us about the question. And it's asking per state, per gender. Wow, this is difficult. Okay, so again, we'll take it one after the other. DF underscore plain. Then, can we try counts? We can count the number of gender in each state. Yes, we can say state, gender, sex. Run and run. Yeah, we can do that. But this is not what the person is asking us for. He's saying for each gender, tell me in each state, tell me the average weight, age, the average height, the average weight. It means that we'll probably need additional columns here, one for age, average age, the other one for average height, and the other one for average weight. Oh, this is difficult. You can use count to do it, but we won't be using count right now. So we're going to use a different function because using count to try to do it is extremely cumbersome. So we won't use count. Instead, there is a function called group by, group underscore by. Yes, and somebody is asking, is there a function like mean? Absolute. And we're going to see mean in action now, right? For average. But before we do mean, we want to group by we want to group it by state and by sex, because our main analysis is going to be for each state and each gender. So we're grouping it by those two criteria, right? Then, if you recall when we were talking about statistics yesterday, descriptive statistics, we talked about measurements of central tendency and measurement of dispersion. And we said examples of measurement of central tendencies are mean, median, and the mode. Obviously, mean is a summary statistics because it tells you the average of something, all right? So there is a function called summarize by. Summarize, not summarize by. So we want to group by this, and then we want to produce some summary. The first one is average age, and we want to say is the mean of what? Age. Let's look at what we have done. Oh, this makes sense. It has given us for each state and each gender in each state, it has given us the average age. And we know that the average age for males in Rivers is 40.2, for female is 39.9. So this is lovely. So let's go over the function again. We've taken our data. We are grouping it by the sex and the state because the person is interested in the outcome for sex and state. And because average is a summary function, we are calling it the summarize. It's a summary. Average is a summary statistics. We are calling the summarize function. And we're saying summarize the mean of age. What if I did not assign it to average age? It will still work. But my column name will really not be exactly what I want it because I will just take the mean of it as default, but we want it properly named average underscore age, right? And then we're going to do the others. Average height equals mean of height. And the last one, average weight equals mean of weight. If you want to know a few more things, let's say the person is also interested in the standard deviation. SDH is equal to the SD function for standard deviation. So we're giving extra icing on the cake. SD weight, we call it SD. Wait, sorry, SD height. This is height. Okay. Icing on the cake. Oh, we have not just calculated the average for you. We thought you might also be interested in the standard deviation. I will give it to you before you ask. And thank you. The person is telling me which height. Is it height in centimeters or height in meters? Let's say we want to calculate the height of the one in centimeters, and weight is definitely kg. Okay, so put our CMs. Thanks, people are following me, right? So we're going to run this now. Lovely. We have our average age, we have the standard deviation of age, which is actually quite high, right? Then we have our average height and the standard deviation of height, average weight, and then the standard deviation of weight. This is nice. So we have answered the first question, we've answered the second question, and we've answered the third question. We have two more questions that the person has asked us to explore. But the two additional questions have to do with plots. Plot a graph of the gender distribution, and then plot a graph of to demonstrate the relationship between the weight and the height. Plots are for tomorrow, so we're going to look at plots tomorrow. But before we wrap up the class today, I just want to quickly just add one more thing. Please, when you are calculating summary statistics like mean, standard deviation, it is good to always consider what if there are missing variables? What if some columns are missing? And how will I handle that? William, I'm sorry to hear. I think rain is a good thing. Most places it's really no longer rainy, but I hope it really doesn't mess up with your network too much and you are able to follow us. And so I was talking about what happens if you have missing variables. And I'm going to show us in a bit. Let's say I have a group of data. I call it my data. I'm going to just write some figures. One. Let's say I have this. I can calculate the mean of my data, right? And I'll get a result. It tells me, but what if for some reason I have one missing value? I recognize this missing value as any, meaning not available. What will happen if I try to calculate the mean of this, even though it has just one missing value? It's going to throw me not available. R doesn't know. Why? Because this any could be anything. But sometimes we know that there might be some empty rows or empty cells when we collect data. How would we want R to deal with it? Ordinarily, some package, some softwares, they just skip the missing ones and they don't use them at all. But in R, you will have to be explicit with that by telling R that what na.rm equals true. So what R is asking by the na.rm argument is that, do you want me to remove the NAs? And you say, yes, 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 go ahead and remove the NAs. All right, and when you execute this, you get your results. So what I'm saying is this: when you are doing summary statistics, please, as much as possible, always try and include na.rm equals true. Because right now, when you are doing the analysis, there may not be some missing entries, but the data collection is still ongoing. In the nearest future, there might be some missing entries. And then you start getting some funny results. And you wonder, oh, why am I getting some funny results? Or maybe after you finish doing the analysis, the person realizes that, oh, I have some cells where these values really don't make sense. And then deletes them and runs the code. And everything starts giving any, and the person is like, what, something happened, your code has broken. It's not really the code that has broken. It's because when there are missing variables, you really can't perform summary statistics, except you remove those missing variables. All right? So we're going to run this again. I'll still get the same result. Okay, so we're going to save this. So a summary of what we've done today. We set up our environment, and we said, if you want to create new folders as much as possible, please create those folders in R. So we use some functions from the DevTools package. We use the use directory function and the use R. The use directory is used to create a folder. The use R is used to create your R script. And that was what we used to create our script. And it automatically saves anything use R. It saves them inside your R folder, okay? Now, we decided that when we want to do your analysis, always think through these steps. Most analysis will require you to load some additional libraries in addition to the base libraries. We have to involve you in importing your file. You will probably have to do some cleaning. You have to do some exploration. You might have to do some visualization. You might have to save some of your outputs. Right, we're going to be saving our outputs tomorrow, and we'll also look at that. And we have used our Control plus Shift plus R to create our headers, these headers. So I can easily fold my load underscore library. I'm able to focus on my data cleaning. If I want, I can also fold that, and I'm able to focus on my exploration, answering some of these questions, all right? Okay, and I can also open them up if I want. Just go ahead and click it again, and then that. All right. Again, how we created it was by just pressing Control plus Shift plus R. Okay, so we started with loading our libraries. We agreed that we're going to use a few packages. So far, we have not added an additional one. Maybe by tomorrow, when we're looking at plots, we might end up adding a few more. But for now, these ones have seemed to have worked very well for us. And we're practically using functions from all of them. The downloader package was what we used to download our file from the internet. We use the reader to read in our text file. Real is where we get our import function from. Here is what we've been used to change names. Deviation function. Idea is where we got our separate function from that we used to separate the BP column into systolic BP and the diastolic BP, right? And the lubricate we used it to manage our date. So we've actually used all of these steps, right? And then the next thing is that we did import our data. This is the URL where our data is hosted, is on the internet. So we have the link, we just copy the link, and then we assign it to something called URL. You can assign it to anything, all right? Another common thing you see is paths or file paths. Assign it to, and then we call the download function from our project directory, go to data directory and put it as demo underscore data. That was how we got it here, all right? We did a few more things. We opened our CSV file up and we decided to save it as text, please, right? And then we created the link that this is the path to our CSV file. And then we try to import it by using the import function. We said when you are dealing with CSV and Excel, just use the import function. It does every other thing for you. But it's always good to set the class to table so that it prints a nicely formatted table for you and not something cumbersome or untidy. So clean names here helped us to clean our variable names, right? to snake case format. If you want it as camel case, yes, you could actually change it to camel case, but I'm not disturbing us with that because I've encouraged you all to use the snake case, which is the default setting. We did the same thing with Excel, but then we noticed that Excel did something to our file. It did change our date to a date time, which is not what we asked. And the next thing we did next is said, for the text file, Excel, of course, did something else again. That's not really because Excel wanted to do it, because Excel might not do that on your computer. Excel is doing it because my computer time is formatted as day, month, year. That's the format for the default format for my computer. Okay, but I didn't ask Excel to convert my column to the default format for my computer, but Excel did that without my permission, all right? So I needed to worry about that. So we had to do the cleaning for those things. So we had to format our text by converting our date to standard date. And we used the day, month, year function from global date. We also had to do almost the same thing for our Excel by using the as._date function. It's also from the global date package. And then we said, okay, all our files are the same. So we can go ahead with any of them since we've gotten the same thing for the three, all right? So we needed to check the unique entries for sex, unique entries for state, unique entries for married, and we realized that some data entry errors occurred with sex, and we had almost 8 different entries. So we agreed, oh, we'll have to change it into just 2 unique entries, male and female. We agreed to that. So that was the first thing we did, and we used the if_else function, if else, said, you see all these multiple entries of male, convert all of them to single male. Every other entry, convert them to females. Very good for us. The next thing we did, we said for sex, also now change it to factor because it's just one of 2 possible outcomes. It should be a factor, not character. State should also be a factor, not character. Married should be logical. So we changed it from yes, no to true, false. Then we manipulated height and changed it to meters. We calculated our own BMI and realized that the default BMI the person gave us was wrong. Okay, then the last thing we did here was to separate the blood pressure column into 2 by stating the point, the junction at which we want the separation to occur. We said is at the / and we asked R, convert them. If you realize that they are numbers, convert them, integers, convert them to integers, if they are doubles, convert them to doubles, right? And that was it. We finished cleaning it. So we started we started answering the respondents' questions now. The first thing is how many people from each state? So we just counted the occurrence for each state. Now, how many persons have systolic blood hypertension? We have done that too. Okay, and then we said, and we gave 2 different ways to do that. And then the last one we said is that person wants to know what's the average age, what's the average weight, what's the average height for each gender in each of the states. And then we did this. We used the group by to say, okay, group, and then all these summary statistics, we put them together. All right, so this is what we're doing today. Tomorrow, we're going to look at our plots. We're going to be plotting some wonderful charts, and we're going to look at being the last day. Now that you have known this much, how do you continue with your R journey? Where do you go from here? Right, so it's already 8:25. Again, we're about 25 minutes behind schedule. Hope it was really worth your time. We have had so many people who have left already. So we'll see you tomorrow. I hope you are able to make your mistakes. I hope we'll be able to find time tomorrow to address some of the mistakes. I will not want to share this script. Not yet, not today. All right? So that you can try your hands on some of these things you have seen. Make a few mistakes. I'll probably spend about 15-20 minutes tomorrow to just look at some of the common mistakes that we have made. So we'll see you all tomorrow. Dr. Benga, over to you. Thank you so much, Dr. Balogun, for that loaded and explicit section. And I'm very sure that all the participants that waited to this time would actually want to appreciate Dr. Balogun for that insightful session. We are so glad. We know you've covered a lot today. We are hoping that tomorrow you will have time for question and answer. And if we are unable to do that, probably maybe we'll organize a question and answer session where people have tried out some of the things they will have learned from you. And if they are hooked at some point, they can run to us and then ask questions and then get answer to those questions. I think it's been a very loaded one, even though you promised that it won't be as loaded as yesterday, but I think it's very loaded. So people need to go back to the videos, watch the videos, look at their scripts, and then practice it over and over again. Thank you so much. I think we've had a very eventful evening. Everyone, I would advise us to catch some rest, create some time tomorrow, and then try to watch the video again before the final session tomorrow. Thank you so much, Dr. Balogun. Thank you, everyone, for waiting till this time. We hope to see you again tomorrow. Do have a wonderful evening or afternoon, as the case may be. Thank you, everyone.